Good day, fellow scientists. Hope you are doing good. It's a favorite sensei here, Sensei Moha. And today we will be dealing with Euclidean geometry. We will be tackling a past paper question. And from there on, I will show you how you deal with such questions, because of majority of these questions here will be based on proving. So basically, we will be proving. So if you are new to the family, please press the subscribe button down there below, and also that notification bell, so every time we post a new lesson you will be updated, you'll be notified. So don't forget to share the video to as many friends as you can, your cousins, your friends, your mates, and tell them that we are now dealing with Euclidean geometry. So let's start. So now our question says, okay, in diagram below, points A, B, C, D are lying on the circumference. A, B, C, D are on the circumference. We must prove that C2, which is this one, it is equals to B minus A1, which is B minus A1. Ne? So many of you may wonder, how B1, A1, like what is happening here? Remember, ne? So you still remember that rule? I think it's theorem number 5 that says if we have a cyclic quad, the opposite angle in the opposite exterior angle is equals to the opposite interior angle. So we will be using that, ne? The opposite exterior angle of a cyclic quad. You may wonder why they didn't tell us what is a cyclic quad. Remember, by virtue of these points lying on the circumference, and then you can see that this is a quadrilateral. So here, yes, I know they didn't tell us to prove. We can use that, we can use another rule. Ne? So now, let's start. So D1, ne? So you can see we have triangle ADC. Ne? So now we know that angle D1, so which means whatever we will be doing, we must consider this triangles. Ne? Sorry, this angles 3, 1, 2, and 3. Ne? So which is whatever we'll be proving, we must consider them. So in triangle ADC, we know that D1, so in this angle in triangle, it's equals to, and here it's the opposite exterior angle of a triangle. So right now we will be using this one or the other one. Ne? I'll just show you what they will still give us the same answer. Ne? A1 plus C2, which is equals to the opposite exterior angle of a triangle. Ne? So now we know that we have found D1 in terms of A1 and C2. Ne? So now, ne? Secondly, we know that this is a cyclic quad. Ne? So the angles, when we add the angles inside this triangle, so this is our first rule. So we know that, okay, let's do it in terms of A1. Ne? We know that therefore A1 is equals to D1 minus C2. Ne? So now we know that we know the value of A1. Ne? So now D2, ne? We know that D2 plus B, D2 plus B, and here there is a cyclic quad. So if we add them, they will give us 180, because of they are opposite angles, opposite interior angles in a cyclic quad. Ne? Ne? You may say also this is cyclic quad because of they touch at the circumference. Ne? If probably one of them maybe they didn't touch, maybe B was here, then it was not gonna be a quadrilateral, and then it was not gonna be it was never gonna be a cyclic quad. Ne? So now we use that. So now B, now we can now do this in terms of B. So whatever we see here, we do it in terms of b. So now we know that b is equals to 180 minus d2. Ne? So now 180 minus d2. Ne? So now we have to find c2. Ne? Or here, okay, we can also say c2 equals to d1 minus a1. Ne? Therefore, so now we know that c2, we know the value of c2. Ne? So now that we know the value of c2, ne? Which is this one, so now d1, and yet even though here we don't have d1, so we cannot really prove that it is there. So which means we have to find d1 in terms of now b. Ne? So we know that d1 in terms of b, we know that d1 it equals to 180. Okay, let me just do this first. Let me erase and just do it step by step. d1 plus d2 equals to 180 because of the sum of angles on a straight line. Ne? On a straight line. So now we know that if we do d2 as the subject of the formula, d2 will be equals to 180 minus d2. Ne? So now we know that b is equals to d2. Basically, d2 is the same as b because of it gives us the same answer. d1 is equals to d2 minus, so now we know that d1 is equals to b. So therefore here we can substitute that d1 is b. Why? Because of the answers are the same. Ne? So now b minus a1. That's how basically we prove it. So remember, the first thing that we did here is we need to check what we given here, c2. We need to prove c2 equals to b minus a1. So we need to find angles. Prove for what are these angles, using the properties of the triangles and cyclic quadrules. Or okay, d1, a1, a2. Ne? So b, we have found for okay, b plus d2, when we add them, they give us 180 because of their interior angles in the cyclic quad. They are equals to 180 or supplementary. We know that d1 equals to both of these ones added together. Both of these ones added together because it is the exterior angle of a triangle in this triangle ADC. So from there on, we now found this. So now that we found this, you can see that it is closer to that. So basically, now that we found something closer, we just basically have to prove d1 in terms of b and see if it's the same or not. Then we did that by a1 plus a2, and yet we know that this one and this one are more or less like similar, and yet therefore we can find in terms of d1, we can find b in terms of d1 basically. So that's what we were doing here. Then after that we substitute because of a1 minus d2 equals to b, and it is also the same as d1, hence why we substituted. So that's how basically we do this question. So it was very, very, very nice doing this lesson with you, and I hope you enjoy the lesson. I enjoyed the lesson. And don't forget to press the like button, share the video as much as you can, and enjoy the rest of your day. Bye bye. Join us next time on the next video, where we will be doing another Euclidean geometry question. Sharp.